Hello guys, so let's start our NLP lecture, and today is the last day of NLP. Today I will bind up the lecture of NLP, and so let's start our NLP discussion. So I have completed all of this like RNN, LSTM, RNN, and today also I am explaining you LSTM, RNN, but today I will explain in-depth intuition about LSTM, RNN, how LSTM, RNN will work. Previously we have talked like how RNN will work and what is the cause, like why we don't use RNN. So the problem is RNN is basically a vanishing gradient problem, and other we can say a dead neuron problem is there, and the context of the previous word they can't capture if the length is very huge. So there's some problems in RNN, so LSTM RNN will help us to reduce this problem in some extent, but it is not 100% good. But transformer we can see, and other like new models like BERT, GPT, something like that, they are able to solve this problem to some extent, like, but in future some model will come and will help us to capture good information. Like if the then sentence length is all very huge, they can able to capture it. So let's start our last lecture of NLP, and today we will discuss like how LSTM RNN will work. So we have already discussed like RNN, how the RNN will work, and how all of this like. So problem with RNN is like, if the suppose we are talking in first sentence like on Sunday I want pizza, but on Monday I want to eat something. So this can't able to capture it. That's why this is the problem in RNN. So this problem is solved by LSTM RNN, because this will able to remember long term dependency. So how this will be able to remember it, let's discuss it. So basically in LSTM we have seen our diagram. Here you can find it, the whole diagram is this, you can find it. So let's break down every basically step, and let's see how this will work. So let's start it. So here we will pass our input, and this input basically pass ht of -1, and again at the time frame of 2 we will pass this input, and the previous output of this layer will be pass as a also pass, so the in the next layer, so that we can get the context of the previous word, so that we can predict the next word what will be the possible next word. That's how this will work. And traditional RNN we already know that. So suppose now, so why LSTM RNN? So RNN is problem like this can't able to remember the if our context vector is dependent on second or third sentence. So LSTM will help us to remember this word. How this will be able to? So we have already seen that like upper layer, this layer basically known as long-term dependency layer. So this layer will help us to remember like what I have to remember and what I have to forget. Like if the sentence length is 3 or 4, this will be able to remember it, all of these things. So let's see how this will work. So this cell, basically the upper layer, we can see this known as a memory cell. So this will help us to remember the long-term dependency context vector. If we are talking like so now of NLP, then model will be able to like remember this, like how, whom, like if the sentence length is 2 or 3, this will be able to remember it, like whom I have to refer now. Suppose my name is Nancy and I, so I, whom I is referring, so this will be able to remember this by using this memory cell. But in RNN this is not there, so this can't be able to remember it. So that's how it will work. So in this layer we have to add some info or remove some info, like if the, so like what I have to remember and what I have to forget, this layer will help us. Like how this will layer help us? So here we will pass a new input, and the previous output of this, there here we have two inputs of the previous layer. The ct minus 1, you can see that it is a long term dependency context vector, and this ht minus 1 is a short term dependency vector. This short term dependency vector and the new input basically passed and concatenate here and apply a sigmoid function on top of that, and now we will get some new vector, and this vector will be applied in the cross manner. Cross means basically a point wise cross vector is applied. So this will help us to like what I have to forget and what I have to remove from here, we can get it. That's how this will work. So suppose Chris like pizza but he does not like burger. So whom he is referring? So Chris is referring, and like Chris like pizza but his friend. So that's how like whom now he whom he is referring Chris, but here is we are talking about his friend. So here we have to add some info like now the context is not changed, we are now talking about Chris, but here the context is changed, we are now talking to his friend, not Chris. So that's will be able to remember by using a LSTM model. So basically I am following this lecture of Chris Nayak. I think you already know that he's a very very good teacher. I i basically follow him from past 2 years and get some very good deep understanding about deep learning, machine learning because of only Chris Nayak. I give him a very very thank you. Yeah, so that's how like listen very carefully. Chris like pizza, but he does not like burger. So here the context is not changed. So here we will get a vector which is near the y. But here what Chris like pizza but his friend. Now we are talking about his friend. So now we have to forget about Chris. Now we have to focus on his friend. So by using applying across function, we will get a different vector. Suppose ct minus 1 is getting a 0.9, and like our ft vector is basically we will get about approx to 0. So by applying this we will get a 0 0 vector, so that we will forget about this information about Chris, and now we have to add some new info. That's how this will work. Actually this layer will plays a very very important role. This only because of this layer only we are able to add some new info, and what like this will help us to what I have to forget and what I have to remember. So if the information is about on the previous vector or previous context, then this will able to retain this information. If now we have changed the context, we are talking about his friend, so we have to remove this information and add the new information about his friend. So that's this layer will help us to remove and add some new information. That's how this will work. A input get layer, this is the input get layer. You can see that HTML. So here you can see the again this is done. Now we have applied a second layer alpha and 10h. Like 10 alpha is basically a sigmoid activation function, and 10h is also a sigmoid activation function. Like another 10h is another activation function, and again we apply a cross function on these two, and we will get some new vector, and then again we will apply a cross vector, or we can say here not cross like here we apply a concatenation vector, or we can say adding information. New information will be passed here, and this will be again like added to our previous information that we will get. So that's how this will work. Like here you can see that ft cross ct minus 1, this is your ft, and to ct minus 1 this information will be point wise cross operation is done, and plus it, this information basically known as I of t cross ct. Ct means this information is all. So that's how this will work, and both of the output of this layer will be passed to the next layer. So that's it for today guys, and this is for LSTMRNN. Basically I have done all of these things in the previous lecture, so that's I have done it in a very minimal time. So that's it for today guys. Output getter layer, this is known as output getter layer. Data is valued only important data. Yeah, so this is also output, and we will give two output to this second layer. So the here you can the below layer and upper layer. Below layer is basically a context vector of the small remember things, and this is a long time dependency context vector, and this is a small time context dependency vector is there, and these two information is passed to this next layer. That's how this will work. Basically, remember only this thing. Here we are applying a sigmoid activation function, and then we are applying across vector. So this will be able to remember like what I have to forget and what I have to remember. This layer is only will help us to getting the capture of information of the previous context vector. That's it for today, guys. Let's meet in the next lecture. Jai Hind, Jai Bharat. Please subscribe my channel also, so I get motivated to create this like video. Basically, I am planning to create a in-depth video from starting like machine learning to deep learning and data science, all of NLP related type. I will create in-depth intuition video. Let's meet in the next lecture. Basically, NLP is now over. So what I have to planning, basically, I think yeah, again, generative adversarial network is also left. So basically, I also explain the generative adversarial and how generative adversarial network will work. All of this thing I will explain in the next lecture. Thank you, guys. And after this, basically, we will start from starting like from machine learning to advance. Thank you, guys.